Earlier this year, we graphed lines in the form y equals mx plus b, slope-intercept form. We also use point slopes, so we know that these geometric figures that they're working with, like lines, can be put on graph paper and have equations. You have previously graphed parabolas, so you know they have equations as well. Well, a circle has an equation also. If the circle has a center, as shown in the picture, at the point HK, and we let the point XY be a random point on the circle, it might be anywhere, then we can develop the equation of the circle. The point directly below XY would have the same X coordinate as XY does, so its X coordinate is X because it's the same distance over, and it's the same distance up as the center of the circle, so its Y coordinate would have to be K. So over here on the right side of the circle, the vertical change between xy and xk would just be y minus k, and the horizontal change between xk and hk would just be x minus h. We could then use the Pythagorean theorem. If we label the radius of the circle as r, then by the Pythagorean theorem, every point on that circle must satisfy x minus h squared plus y minus k squared equals r squared. And this equation is the equation of a circle centered at hk, radius r. So, sort of sloppily here, I apologize, I have summarized the equation of the circle, hk radius r again, and we're going to do an example. We're going to find the equation of a circle with center -2, 3, and radius 9. Well, this a lot like working with slope-intercept with lines is nothing more than just plugging in to the equation. So, the equation says we should take x minus the x coordinate. That would be minus a -2 squared plus the quantity y minus the y coordinate, which would be y minus 3 squared, equals the radius squared. That would be 9 squared. We can clean that up a little bit. That's x plus 2 squared plus y minus 3 squared equals 81. And that's all there is to it. We've come up with the equation of the circle. Okay, we can take that same problem then and we can work it backwards. In this problem, again, I've written just for reference up at the top there the equation of a circle centered at hk radius r, just so we'll remember. And now the question is, let's graph this circle, which is x plus 3 squared plus y minus 4 squared equals 25. First step I'm going to take is I'm just going to put this in the form x minus h squared plus y minus k squared equals r squared, so I can see the center and the radius more clearly. So x plus 3 is the same as x minus a -3 squared plus y minus 4 squared equals 5 squared. So from this, I can see that the center must be at the point -3, positive 4, and the circle has a radius of 5. So just a very rough graph here. Here's my circle. The center is -3, 4. Now if the radius is 5, some really easy points to find would be going 5 units to the right of -3, 4. So I would be increasing the x coordinate by 5, so -3 plus 5 is 2. There's the point 2, 4 that's on the circle. I could have gone the other direction on the horizontal direction. I could have subtracted 5, and that would put me at this point, which would be -3 minus 5, -8, 4. I could have gone up 5 units from negative 3, 4. That would increase the y-coordinate by 5. I would now be at the point negative 3, positive 9. Or I could have gone down 5 units, and that would have given me the point negative 3 for x, and 4 minus 5, which is negative 1, for y. So put that on graph paper. You get a prettier circle if you use a compass, but that's all there is to graphing circles.